Okay, we are quickly approaching the end of talking about imaginary numbers, and I imagine you're sad about that. Okay, but anyhow, let's talk about a few more properties of the conjugate. The conjugate of a real number is just the real number. So 2 is its own conjugate. You can almost think of it this way: 2 plus 0i. And you say, okay, well, the conjugate would be 2 minus 0i, but minus 0 and plus 0, you don't need to write either one, so in either case you get 2. Some other properties of the conjugate, and I guess I should explain this line above my letter here. Z is a complex number in this problem, in these problems. Z is a complex number of the form a plus bi, and if you put a line over Z, that means take the conjugate. So the first one says the conjugate of a conjugate is the number itself. Second one says you can either add two numbers and take the conjugate of the whole thing, or take the conjugates first and then add them. And the third one says the same thing as far as multiplication goes. You can either take the conjugate in the beginning of each one separately, or take it of the whole thing at the end. Now, another property of imaginary and complex numbers that's important, we need to talk about powers of I. So if you look, I to the first power is I. That makes sense. I squared, by definition, is negative 1, because I is defined as the square root of negative 1. So I squared, by definition, is negative 1. Now, I cubed, you can write as I squared times I, but we already know that I squared is negative 1, so I get negative 1 times I, or negative I, and that's what you see in my notes. And then I to the fourth, well, you can think of that as I to the third times I, and this is kind of what we call a recursive relationship, which means the next property builds on the one before it, basically. So I already figured out that I cubed was negative I, so I get negative I times I. That gives me negative I squared. Well, I squared is negative 1, so I get negative negative 1, or positive 1. Now, if you multiply by another I, that gets you the I to the fifth, but we already know that 1 times I is also I. So I to the fifth can be rewritten as I, and you can repeat this process. I to the sixth would be I to the fifth times I. Well, we already know I to the fifth is I. Times another I, you get I squared, and the pattern repeats. So any power of I can be rewritten as either I, negative 1, negative I, or positive 1, any power of I. Now here's how I do it in practice. Let's say I want to find I to the 63rd power. Now I am probably not going to say, okay, I to the 1 is I to the 2 is negative 1, then I have a negative I, then I have a 1, then I. I'm probably not going to count, because those four numbers keep repeating. I'm probably not going to count to 63. What I will do instead is I will split this up into a power that's divisible by 4, the largest one that I can. So I think I can write this as I to the 60th times I cubed. Because I to the 60th, you're probably saying, well, why did you do that? Why do you want it to be divisible by 4? Well, because then I to the 60th can be rewritten as I to the 4th raised to the 15th, because when you raise to a power, you multiply exponents. Well, I to the 4th is 1, so 1 to the 15th is still 1, so I have 1 times I cubed, and we already know I cubed is negative I. Okay? So let me give you the shortcut one more time, because, I kind of went through it, all at once. Let me kind of summarize what I did here. Anytime you want to find a lower power of I, because you should never have more than I, negative 1, or 1. Anytime you want to reduce a power of I to one of those four things, split it up, whatever the number is, like let's say 101, I to the 101. You split it up into a power divisible by 4. As you can see here, the power divisible by 4 is going to end up being just 1 times your leftover, which is either going to be I cubed, or I third. In this case, it's I. So split things up into a power divisible by 4. That part cancels out, and your leftover is either going to be I to the 1, I to the 2, I to the 3, and you can figure out each of those. Okay?